where are we going today? Do you have a Canvas? Do you have something on Math Excel?
I just took a test.
Yep.
I'm technically in geometry right
Yep.
now, but last year for algebra, I really didn't understand it, so I was hoping to do more algebra review.
Okay. Okay. So, do you have anything in mind, or do you want me to go to the web and find some stuff to look at?
Could you find some stuff to look at?
I could. Now, if that's the case, then what I'm going to have to do is I'm going to have you click on Stop Share, and then I will
Okay.
click on Share, and then I will go find something here.
Okay.
Maybe. Now, some of this is going to seem very simple to you, so bear with me. But as I scroll up, if you see something that you're like, okay, I do not know how to do that right there, then just know what I wanted. Okay. Are you okay with everything that you've seen so far?
I think so.
Okay. Are you thinking more in terms of solving equations?
I think quadratics and stuff like that.
Ah, okay. All right. Let's see if we can get to that. And if I can't find anything in here, I'll pull up some of my Algebra 2 stuff. Are you talking about factoring quadratics?
Yeah.
Okay. All right. So here are some factoring questions. Let me get my... So, the first thing that we always look for is a greatest common factor. So every time I see something, now this obviously starts out with a 1p squared, so there's nothing that I'm going to be able to pull out of all of them. But whenever I see something like this, I'm looking to see what can I, if anything, can I pull out of those. I do see something in number 71 that can be pulled out, but we'll get to that in a minute. So if I can't pull anything out, then I have to think about what would I multiply together to give me p squared. Well, if you remember, that's the easy part, right?
Yeah.
Okay, so really what I need now are things that multiply together to give me 18, but they have to add, and when I look at that sign, I see that they have to add up to -9. Now, the only way two numbers are going to add together to give you a -9 is if both of them are negative. Now, if we subtract two numbers, and we can always come up with a negative as well, but if I'm adding two numbers together, I have to add two negatives. So can you think of a combo that multiplies together to give me 18 but adds up to -9? Would it be 18 and 1? Is that possible? Do they add up to -9?
No.
Okay, so how about 9 and 2?
No.
6 and 3?
Yes.
So that's what I know. That's when I know I've got my correct my correct sorry, I am not seeing my recording controls. I'm not sure why. I'm not seeing them. Oh, there they are. Okay, I'm good. I was panicking for no reason.
Okay.
Okay, let me clear that out. And, oops, that is not what I wanted. All right, now on a question like 71, What is a common number that you can pull out of those? Now, to make it easier, let's think of something that goes into 15. So what are a couple different numbers choices that you have for numbers that go into 15?
5 and 3 is
Okay.
the first one I think of.
All right, yeah, that's great. Now, so start with the 5. Do you think 5 goes into 132?
Probably not.
Okay, how do you know?
Because the 2 is not divisible by 5.
Yes, exactly. You either have to have the last digit has to be a 0 or a 5 in order to be divisible by 5. Now, that's called the divisibility rule of 5. Do you know the divisibility rule of 3? And I'm going to guess you don't, because most of the teenagers that I know, not only in geometry, but in Algebra 2 and pre-calc, don't even remember the rule for 3. But if you do, I'll be very impressed.
I don't.
Okay, most kids don't remember this, and when I tell it to them, they're like, oh my goodness, nobody's ever told me that, which is not true, but, they just don't remember it. So what you need to do is you need to add the digits together. So like if I took the numbers from 15, 1 and 5, and I add them together, what do you get?
6.
That number is divisible by 3. That's how I know that 15 is divisible by 3. Now, so what about 1 and a 3 and a 2? What do they add up to?
5.
Try again.
6.
6. They add up to 6. So you can see that's another number that, what do 9 and 6 add up to?
15.
Yep. Now, suppose you didn't know that 3 went into 15. You could continue the process by taking the 1 and the 5 and add them together until you got a single digit. So you can keep doing it until you get all the way down. It's kind of an unusual thing that you are allowed to, that you can do, but it only works for 3s. It doesn't work for anything else. I know everybody wants to use it for everything else under the sun, but they can't. They're always like, does that work for 7s? And I'm like, no. So if I take a 3 out, what am I left with? So what I'm doing is I'm going through and I'm dividing everything by 3, and I'm telling you what's left.
Okay.
So what is 15 divided by 3?
5.
So I would have 5v squared. What's 132 divided by 3?
44.
Okay. And 96 divided by 3?
32.
Okay, now, that question I'm going to come back to because, now, maybe I should go ahead and do this one with you. Because now it has, have you ever heard of something called the Berry method?
No.
Okay. So when I was in school, nobody taught me the Berry method. They made me guess and check and guess and check and guess and check until I got the answer right. And it was very frustrating to me. A couple years ago, probably about 6 years ago, I learned of another way to do this problem. It's going to kind of look like a double magic trick, but I take the 5 and I multiply times the 32. And I'm going to write this down. V squared plus 44v plus, now 32 times 5, I think that's 160. Okay, now I'm going to factor this polynomial. Okay, so we've got v and v. Now I need to come up with factors of 160 that add up to 44. Now, there's a lot of factors of 160, but they need to be fairly close together. Like 160 and 1 would not work at all, right? They don't add up to 44. So what I need to do is I need to push the factors closer together, okay? So, if I did something like 80 and 2, they're getting closer. How about 40 and 4? Does that work?
Yes.
Okay. So that makes my life a lot easier because now I know it's plus 40 and plus 4. Now, what's interesting at this point is here's the second part of the magic trick. The 5 that we originally got rid of is now magically going to come back in front of both of the V's. Okay? And the other day I looked up the proof of this. I would never, ever, 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 ever show a kid the proof, the algebraic proof of this, because it's very long and complicated. But it's definitely very interesting. Now, the last thing we need to do is we need to look here and see if there are any GCFs that we can pull out, because in this process we have basically introduced extra greatest common factors that we don't need. At least one. Sometimes two, but at least one. Is there anything in common to 5 and 40?
8? Wait, no, 5.
5, right? Okay, so now if we take that 5 and we pull it out, what do we have? If we pull out a 5 here, wouldn't we be left with V?
Yeah.
And if we pulled out a 5 out of the 40, what would we be left with?
Do I divide it out or just
Yes, yes, you're just dividing it out. When we say factoring out, we're always talking about division.
Okay,
So
use 8.
Correct. Now, is there a greatest common factor in the other one? And the answer is no, there's not. So I have to leave it alone. Well, guess what we just did? We found the exact, if I were to take V times 5V, we'd get 5V squared. If I take V times 4, I get 4V. If I take 8 times 5V, I get 40V. And if I take 8 times 4, I get 32. And then if I add the terms in the middle, guess what I get? I get the exact same thing that we had up here. So, so the 3 comes down because it was part of the original problem. And then this line right here is going to come up here and be the last part of my factoring. Now, that's about as complicated a factoring as you're going to get. I mean, that right there, to be able to take this and make it look like that, that is probably the most difficult factoring they're going to have you do. So basically I feel like I threw you into the fire instead of, like the first problem we did was nice and easy. And I should have found a few more like that. The one thing I wanted to do with this particular question was look for a greatest common factor. It just ended up being a lot more difficult problem. And I definitely know that you need more practice with the Berry method, but it really is kind of nice. All you're doing is taking the one thing, multiplying to the end, then you got this 160, then you factor it into 2 pieces. You just have to remember that the 5 that magically disappeared at the beginning is going to reappear, and then you're going to look for any greatest common factors to eliminate. It does take practice, but I know that once you got the hang of it, you could do it well. Let me see if there's any other easier ones than... Okay, how about number 70 here? That one's probably a much nicer one. We definitely have P and P. Now this one, the end product has to be a negative number. The only way that can happen is if one is a positive and one is a negative. So, what kind of numbers do you know that multiply together to give you 9? But because this is a negative, that means we're looking for a difference, not a sum. A difference of 8. More specifically, a difference of negative 8. Now, the question is it 9 and 1 or 3 and 3? Which one of those has a difference of 8?
9 and 1.
Okay, so I'm going to give you 2 options, and you tell me which one is the correct one. Do you think it's the top line or do you think it's the bottom line?
The bottom one.
Okay, and why do you think that?
Because of the -9.
Good. I'm glad you got that. The positive and negative does matter. So is this kind of ringing a bell?
Yeah.
Okay. Am I doing things that are too easy for you?
I don't think so.
Okay. Okay. Does number 72 have a greatest common factor? Is there any number that goes into 5, 8, and 21?
I don't think so.
You're right. So this is a Berry method candidate. Okay, so let's see if we can practice this. So first I'm going to take the 5 times the 21, and that's going to give me n squared minus 8n. What's 5 times 21? Or negative 21?
105.
Okay, all right. Now let's think about it. We need factors of 105 whose difference is -8. So I know I'm going to have a positive and a negative. So let's start thinking about numbers that go into 105. For instance, does 3 go into 105?
No.
1 plus 0 plus 5. What do you get when you add 1 plus 0 plus 5?
6.
Ah, so 3 does go in. Because 3 goes into 6.
Yeah.
Okay. Why is that on there? I don't know. So 3 goes into 105. Let's see. 3 times, carry the 1. 3 goes into 15 5 times. So 35 times. What goes into 35? How about 5? And it goes in 7 times. Now, what you and I just did was, when I was in high school, they called that upside down division. And what they were really looking for were the prime factors, so that we could see when we had the greatest common factors, when we had least common multiples, but also when we needed to factor. So for instance, I'll show you what I see. What's 3 times 5?
15.
So I have 15 and 7. Notice how those two numbers are 8 units away from each other. Does that make sense?
Yeah.
So where do I put them in my factoring? Which one has the negative, I should say? Is it 15 or 7?
15.
Correct. Good. Okay. Now, what should I put in front of both of the ends? Something should go in front of both of the ends.
A 7. Or a 3.
This is where that magic 5 comes back in.
Oh, okay.
The one that kind of disappeared at the beginning is now reappearing. Now, when you look inside the one on the left, do you see any kind of GCF?
No.
So leave it alone. Do you see any kind of GCF in the next one that we could pull out and get rid of?
A 5.
Take the 5 out, and if we take the 5 out, what are we left with? N minus
3.
Okay, you just factored the original polynomial. Now, if you don't like that, then you're going to sit there and guess and check and guess and check and guess and check until you can figure out how to make it happen. Which, that's fine if you like that idea. If you want to sit there and go, okay, what are my factors of 21? Because, you've got this 5n here and a 1n there, and now you have to start messing around with numbers until you get the outsides and the insides to add up to -8n. It's not, obviously that's what they taught me to do when I was in school, so, I got it, but it just took a lot longer.
Yeah.
When you look at number 74, is there a greatest common factor you can pull out?
No.
Look again.
3.
Yeah, what's 5 plus 1?
6.
Ah, so 3 does go into 51. Now, I'm going to show you a dirty little trick. When I look at this polynomial, instead of pulling out a 3, I'm going to pull out a negative 3. So the reason is I don't like dealing with an a squared value that's got a negative number in it. So if I take the negative outside, I would be left with 10a squared. Now 3 goes into 51, I think 17 times, but I have to change the sign. Do you know why I have to change the sign?
No.
Okay. Remember that factoring is division, right? So all I'm doing is I'm going through and I'm dividing everything by negative 3.
Oh, okay.
Okay. So what's that make my last term over here?
6.
Positive 6. Now, we don't have to do that one at the moment unless you want to. That's another Berry method one. But what I wanted to show you on this one was whenever you see that negative at the beginning with the squared term, do not hesitate to pull that negative out so that you end up with a nice positive squared term. Most kids fall apart because if they remember to pull out a 3, then they look at it and they're like, I don't know what to do with that negative 10. So just make sure that you pull the negative out with that. You know, I've even seen problems where it's like negative a squared. Let me think here. Let me make one up in my head here. A squared. I've seen questions like this, and kids didn't know what to do with it, where if they would have just taken one moment and pulled out the negative 1, then they would have seen something very much like what they're used to dealing with. So even if it's just a negative 1, pull it out and then look at what's left and say, oh, okay, yeah, I know what to do there. Yeah, that's a plus 6, a plus 1, you know?
Okay.
So watch for those tricks if they're going to do something like that. Now, you're in geometry right now. I doubt that they're going to be doing much with factoring or quadratics. Now, they will do some. I shouldn't say that. They will do some. I have seen questions where they'll have like a box and it's got, 2a plus 1 and 3a minus 5, and they say things like find the area. So,
yeah, we just did that.
Oh, you just did that?
Something similar, yeah.
Okay, so was that hard?
Not really.
Okay.
I think there were easier problems, but
what if did they do anything like let's see. The area equals 6a squared minus 7a minus 5 find the width.
something easier, but like the same concept, just like easier problems.
Okay. So if I gave you this question, would you know what to do with it?
Yeah, I think I could.
Okay. What would you do?
I'd find A out of the problem.
Okay. Now, do you know that the answer to this question is not going to be a number? The answer to this question is going to be a factor. So, can you tell me what factor I would need? In other words, you and I have been doing factoring. And if I gave you one of the factors, could you come up with the other factor? For instance, what multiplies 2a times what to give me 6a squared?
3.
1 times what gives me negative 5?
5. 5. Negative 5.
Negative 5. So the answer to the question that I asked was right here. W is equal to that thing. So it was basically a factoring question, just written in the geometry kind of way.
Okay.
So you guys didn't quite do anything like that?
No.
Okay. Can you give me an idea of something? Have you done anything with quadratics recently in kind of somewhat of a review fashion, but maybe had a geometry twist on it?
No, I don't think so.
Okay, so you just kind of wanted to refresh your memory on some of that?
Yeah, I really didn't understand much last year.
Really? So like, oops,
Yeah.
sorry, I accidentally clicked the wrong button. So what about this one right here, 76? That's kind of a different one. Does it have a greatest common factor?
No.
Okay. Do you recognize this one?
I recognize it, yeah, but I don't think I could tell you what to do with it.
Okay. It's called a difference of squares. Okay. Maybe I can make a different one that's easier. Do you remember things like x squared minus 9?
Yes.
How did we factor that one? Like, let's just walk through it. What would the first two things have to be?
You gotta put x,
Okay.
and then the other x,
All right.
and then the 2 signs, which positive and a negative.
Correct. Now you need two numbers that multiply together to give you 9, but I want you to notice something. There's no middle term. Do you recognize that?
Yeah.
Okay, so that middle term is actually 0x. So we could have written it like this, x squared plus 0x minus 9. So we need them to add up to 0. What would we have to do? Is it 9 and 1 or is it 3 and 3?
3 and 3.
Yeah, because one's positive and one's negative, right?
Yeah.
Okay, so how do we go from x squared to x? What operation did you use?
Square root.
Correct. You use the exact same operation to get from 9 to 3. So you took the square root of x squared and the square root of 9, and one's a positive and one's a negative. Okay?
Okay.
Now, go over to question 76. Okay, we're going to do the exact same thing. What's the square root of 16m squared?
8m.
Well, take it one step at a time. What's the square root of 16? And what's the square root of m squared? Now, you got the m part right. But what's the square root of 16?
4.
4. So we have 4m and 4m. Now I need the square root of 25.
5.
Okay. 5 and 5. One's a plus, one's a minus, and now we're done with the question. So it's exactly like the x squared minus 9. It's just, yeah, it looks a little bit bigger. But, you know, it's the same concept. You're square rooting each of them and putting one positive and one negative.
Okay.
Does number 78 have a greatest common factor?
3.
Hold on, I need to scroll it up. 3, well, not quite, because 3 doesn't go into 16. 1 plus 6 is 7, and that doesn't divide by 3. So 3 does go into 9 and 24, just not 16. So I guess the answer is no. There's nothing in common to all of them. So I guess this would be one of those Berry method problems. So we'd have x squared plus 24x. So take 9 and multiply times 16. What do you get?
144.
144. Okay. So now we factor it. We know it's going to be x and x. We know because it's a positive 144 that they're both pluses. So we need to think of things that multiply together to give us 144 but add up to 24.
12.
12 and 12, right?
Yeah.
Okay. So now what's going to come back in front of... What's going to come back in front of both of these x's?
A 9.
That's right. So you tell me, when I pull the GCF out of the first one, what am I left with?
Out of the one in the green or the black?
In the red.
Oh, okay.
Write this factor 9x plus 12. It looks like I can pull a 3 out of it. If I do, what am I left with?
3x plus 4.
Okay. It looks like I can pull another 3 out of that one. What am I left with?
3x plus 4.
3x plus 4. Now, you notice that both of those are identical, right?
Yeah.
Okay. So that means that I could write my answer like this. Now, what you found, this thing right here, is actually called a perfect square trinomial. Now, one of the things that gives it away is this. Look at the ends. The ends are both perfect squares, right?
Right.
So if you took the square root of 9x squared, what would you get?
3.
3x. And if you took the square root of 16, like we said earlier, you'd get 4. Well, that's each of those, right?
Right.
Well, when you do the outsides and the insides, you end up getting 12x and 12x. And those are the things that add up to the middle term, 24x. So, yeah, come in. Sorry, somebody's... Did you flip that? Okay, good. Click on the light. So the Bears won? No, it's not.
Oh, okay. So they scored. They scored a touchdown, right?
Okay,
Then,
the Denver Broncos scored.
Yeah. So here's what happens. They score, right? And so they're going for 2 because they want to win the game, right?
Yeah.
And they get like what was it? They ran the game clock down.
Okay.
I can't think of the penalty.
Okay.
But anyway,
delay of game.
Yeah, and so it moves them back, and they're like, okay, we're gonna go for the 1, go into overtime. But then we had like an offsides, and they shanked the field goal. But because we had the offsides, they got another chance at the 2-point. So it moves them up. They make that. Then we march down the field till like the 50. Trubisky throws it over the middle to Robinson and gets him into a 53-yard field goal range. And Pinheiro makes the field goal.
Oh, nice.
Wins us the game.
All right.
So
we're big Chicago Bears fans here at our house. And we had a very depressing season last year, so.
Yeah.
all right, sorry.
No, you're right. So, I don't know if your family is big into any particular sport or anything.
I follow college football more than NFL.
Oh, yeah?
But I get the basic gist of everything.
Yeah. Do you play any sports by any chance?
I play volleyball, softball, and then I'm in band.
You play volleyball?